Okay, YouTube, this is my last video on transformations in which we're going to put all of our transformations together to really use our basic knowledge of the parent functions, such as our f of x equals x squared, which is this graph you see over here on the left, which I don't suppose I need to sketch. It starts at 0, 0, goes through 1, 1, and because we've sketched this many, many times, we see that it has symmetry and also goes through 2, 4, and 2, negative 4, negative 2, positive 4. We get this quadratic graph. What we want to be able to do is very quickly sketch the graph of g of x without having to make a table of values. So using what we know about our transformations, let's identify a few key values here. So I notice first of all that this value in here with my x values, really what that's going to do is cause us to shift right 1 unit. Remember that our x value translations here are always backwards of what they appear to be. And this loose 3 out here is always going to cause us to shift up or down, in this case up 3 units. So I know that this graph here is going to be shifted right 1 and up 3 from this initial f of x graph, the parent function, but also this 2 out front, because we're taking 2 times this out front value here. We're going to be stretching our function by a factor of 2. So we say stretch. And just to be clear here, it's vertical stretch by factor of 2. If we had been multiplying our x values on the inside here by 2, then we would have had a horizontal shrink, but in this case a vertical stretch. So using what we learned in this last video here, which is we always apply horizontal shifts first, followed by our stretching or shrinking, then reflecting, and then vertical shifting. What we're going to see here is that this graph right here, we should always, I guess, start by shifting this right 1. So from the original parent function, we would go right 1 right here, and it would start right here. And because I have this 2 out front now, I'm going to apply my stretch here. Instead of going up 1 as we go right 1, which it normally does, we're going to go up twice as far as we go right 1. And because of symmetry, I know that this is going to do this as well. Also, this 2, 4 was now going to be a 2, 8. But we've been shifting right 1. So 2 points to the right of our vertex here would be 1, 2, 3, 4, 5, 6, 7, 8. We're going to have to use our imaginations a little bit. But we'd say that this, because of symmetry, is also at a height of 8. So this is our graph. We're not done yet, but this is our graph that's been shifted right 1 and vertically stretched by a factor of 2. Now because the 2 is positive, we haven't reflected this over the x-axis, but we still have to apply our vertical translation up 3 units. So what this is going to cause to happen is this point now is going to be up 3 units from its initial point. This will be up 1, 2, 3 units from an initial point, and this will be up 3 units from its initial point. And because I don't have much space to move these top 2 points up to a height of 11, I'm going to say let's roll with it here. But basically, this would be the transformed version of our original function, which we can see here shifted. Let's illustrate it here. Right 1 and up 3. There's our right 1 and up 3. And then was vertically stretched by a factor of 2. Cheers.